It's a common challenge for many students are unable to get full mark on the given physics questions, especially on a 4 marker and a 6 marker. Here, I am going to walk through one of the simple and easy to follow tip to secure full mark on physics question. So this is a 4 marker and I want you to spend a minute to go through the background information for the question. This is really important. You need to read the background information. This is going to help you to solve the problem correctly. All right, you can pause the video now and allow you a minute or two to understand the background information. And this is actual question. So you have a background information over here and this is actual question itself. I'll give you a few minutes for you to go over the question. You have a background information for the question. You have the actual question. You have been asked to calculate something, and this is a 4 marker. Okay, so pause the video, take a couple of minutes, find the answer, and then continue. Okay, I believe you have completed your calculation and you have find your answer for the length. Now, is your answer 0.015 meter, 0.0015 meter, or 0.15 meter? Well, that doesn't look all right. If you read the background information, you have been asked to calculate the distance between two electric poles. So, distance between electric pole can't be 0.015 meter. Definitely it can't be 0.15 meter either. So we have a problem. Maybe we had couple of issues on unit conversion. So here I'm going to explain one simple tip. Let's see how we can solve these kind of problems. And I would like you to prepare a little table, something like this. This will help us to identify the given values. So you have been given force, which is 0.045 Newton, magnetic flux density 60 microtesla, current is 50 amps. You have been asked to calculate the length. So this is supplied values. I want you to note it down in this way. So force equal to 0.045 unit Newton, very importantly, note down the units. Magnetic flux density B, which you can represent as 60 microtesla, and current, which is I, value for current is 50 amps. You have been asked to calculate the length. Right, so this is supplied, and I want you to convert everything into SI units. That is what we will be using in the formula. Right, force, the SI unit is 0.045 Newton, so we don't need to convert. Right, however, on magnetic flux density, this is not microtesla. The SI unit for magnetic flux density is Tesla. So how do we convert 60 microtesla to Tesla? I have already shared a video which is available on the description. Have a look at it. So if you want to convert microtesla to Tesla, you need to multiply by times 10 to the power minus 6. So 60 microtesla can be converted 60 times 10 to the power minus 6 Tesla. So this is the key. If you haven't got it right, you will not be able to get that answer correct. Right, so now magnetic flux density is 60 times 10 to the power minus 6 Tesla. And current, ampere, is a standard unit. We don't need to do anything. And length we can easily work out. Voila, now we have got everything sorted out. Now, what is the actual formula what we need to work out? So, whenever you come across a question magnetic flux density, then the one simple formula which would help is F equal to B times I times L. F force in Newton, B magnetic flux density in Tesla, I current in amperes, length in meter. Now we know the force, we know magnetic flux density, we know the current, but we don't know the length, right? Now what we need to do, we need to rearrange the formula. How? Right, so let's rearrange the formula. Right. Can I write this other way around? B times I times L equal to force. Yeah, we can do that. And now I need to calculate L. So what I need to do, B and I has to move on other side. Remember, if it is multiplication one side, when it goes to other side, that becomes division. If it is division on this side, when it go across, that becomes multiplication. So with that concept, L equal to F over B times I. Right, there you go. Now we have got the formula sorted out. We know the force from the table. We know the magnetic flux density from the table. We know current from the table. Apply all the values, calculate. There you go. This is one of the easiest way to get the question correct. Now let's apply all that and let's have a look at the mark scheme. There you go. So magnetic flux density 60 times 10 to the power minus 6. And you rearrange the formula 0.045 force, magnetic flux density times, which is current, 50 amps. And the correct answer is 15 meter. Now, does it make sense? The distance between two poles are 15 meter, which is very, very reasonable. So that's it. You get it right. Okay, so do remember, watch out for the different supplied units. Convert into the SI units. So prepare a little table, convert and get it right and rearrange the formula if required. There you go.